Okay, now let's discuss about multiplication law of probability and independent events. Last time we have discussed about two types of diagram to represent the sample space. They are possibility diagram and tree diagram. In this section, we will learn another type of diagram. So first of all, let's just recall the concept of possibility and tree diagram by solving the problem in this investigation. A box contains of 4 red marbles and 3 white marbles. The marbles are identical except for their color. A marble is drawn at random from the box and is replaced. So here the experiment is with replacement. A second marble is then drawn at random from the box. Now try to represent the sample space using possibility diagram and a tree diagram. So let's just solve the first problem. We need to draw the possibility diagram. So here, first of all, let R represent the red marbles, and then white represent the W represent the white marbles. So we can draw the possibility diagram. Okay, that's if we use possibility diagram. Now what if we want to draw the tree diagram? In this case, we have 4 red marble and 3 white marble, right? It means for the first row, we will have R1, R2, R3, R4, and then W1, W3, W4. And then for the second row, if we have R1 as the first row, we will have, for the second row, we will have R1, R2, R3, R4, and then W1, W2, W3. This is still for R1. What about R2, R3, R4, and then W1, W3, W2, W3? It is not hard, it's easy, right? It is very tedious, right? So that's why later we need to simplify the tree diagrams because, well, if the possible outcomes only 2 components, we can just use possibility diagram. But what if the components for each possible outcomes more than 2? We cannot use possibility diagram, right? We need to use tree diagram. That's why it is a need to simplify the tree diagram to represent the sample space, because we will need it if the components for each outcome more than 2. Now let's try to simplify for this case. We still have first drawn and second drawn. So here actually we have R1, R2, R3 to represent the red marbles, right? For after we simplify it, let's just let R represent the red marbles, the 4 red marbles, and then W represents the 3 white marbles. So we just have R and W for this column. And then let's just put a box here. It will represent the probability of red marbles and white marbles here. And then let's see for the second row. If the first row is red, the possible outcomes for the second row, it can be red or white. So red or white. And then let this the probability again. And then if the first round is white, then for the second round again it can be red or white. From this experiment, what is the probability of drawing red marbles from this box? Red marbles, there are 4 red marbles here. It means 4 over total NS 7. So 4 over 7. What about white marbles? The probability of drawing white marbles from this box is 3 over NS 7. So 3 over 7. This is for the first row. And then for the second row, let's see. If we draw red marbles for the first, we draw the red marble because our experiment is with replacement. It means after we draw the red marbles, we replace it with another red marbles. So what is the probability of drawing red marbles for the second draw? It is just the same, right? 4 over 7 because the case is with replacement. And then for probability of drawing white marble for the second draw is 3 out of 7. So basically it is just the same here because it is with replacement. It means that whatever we get for the first draw will not affect for the second draw. It means if we have white marble for the first draw, the probability of drawing red marble as the second draw is just the same. It is 4 over 7 and then 3 over 7. And then how to find the probability of this? So now let's try to solve the problem from the first diagram here. We want to find the probability of drawing white marble for the first and then red marble as the second. White as the first and then red for the second. It means it is 3 times 4. The probability of white and red is 12 over NS. NS is, this is 7, so 7 times 7, 49. Can we rewrite this probability become PWR equals to white and red? So white marbles is 3, the number of red marble is 4. So 3 times 4 over the possible outcomes for the first draw is 7 times for the second draw is 7. So it is just the same, right? It means that this probability we can rewrite it become this because it is just the same as 12 over 49, or it is N W times N R over NS. And if we want to find the probability that the first marble drawn is red and the second is white, it means NR times NW over NS. So NR is 4 and then NW is 3. So 4 times 3 equals to 12 over 49. Okay, that's if we use possibility diagram. Now let's see if we try to find the probability by using this tree diagram. Of course, for the probability, it should be the same as what we have in possibility diagram. It should be 12 over 49 because it is just the same case but different ways. So probability of WR, it should be 12 over 49. But how can we see it from this diagram? It is just the same concept with what we did in possibility diagram actually. So this is, we can rewrite it become PWR PWR equals, so W is 3 over 7, and then R, red marble, is 4 over 7. So the probability is 12 over 49. Or we can say that if we want to find probability WR, we can just use PW times PR, right? So it means that if we want to find the probability of WW, it means WW, so 3 over 7, it will be 9 over 49. And then if we want to find the probability of RW, it means 4 over 7 times 3 over 7. If we want to find the probability of R and R, it means 4 over 7 times 4 over 7.